All right, in this video I want to take a look at one of the questions that was on your last quiz of the semester, and that was taking the Laplace transform of C, where C is a non-zero constant. Okay. Now, nobody had a problem using the definition of Laplace transform to evaluate the integral. But I became aware as I was grading this and as I was grading your exam, where you also had to use the definition of the Laplace transform, that there seemed to be a lot of confusion about any restrictions that we might have on S. Now, that wasn't worth a whole lot of points on this quiz, and it wasn't worth a whole lot of points on the exam, but I became aware that that's a place that the class is sort of struggling. So, I'm making this video with the emphasis on looking at the restrictions on S. If I ask you to use the definition of Laplace transform on the final exam, you can expect that the major reason I'm asking that is to see whether you've learned how to deal with those restrictions on S. So that will be a much bigger part of the problem as I'm grading it on the final, if it happens. Okay, so the Laplace transform of C, by definition, is the integral from 0 to infinity of C times e to the negative st dt. And I'm going to immediately rewrite that as the limit as b goes to infinity of the integral from 0 to b of c times e to the negative st dt. That's very important. A few people were sloppy on that, okay? I'm ultimately going to take an antiderivative and have to plug in my limits of integration. Infinity is not a number. I can't plug it into a function. Okay. All right, c is a constant, so I'm going to factor it out. So this is going to equal c times the limit as b goes to infinity of the integral from 0 to b of e to the negative st dt. And at this point, I realized that I would like to do a u substitution. The logical choice for u is to let u equal negative st, then du would be negative s dt. But if this u sub is going to work, I would need to introduce a negative s here. And so I'd have to counterbalance with the reciprocal, a negative 1 over s on the outside. I can only do that if s isn't 0. So I'm going to go ahead and do that. But I'm going to acknowledge that it's only valid if s does not equal 0. But I need to be careful. That does not mean that the Laplace transform is undefined if s is 0. What that means is that this particular technique of integration, called u substitution, will not work if s is equal to 0. But just because I can't integrate using this method doesn't mean that the integral would diverge. So that's an open question. I'm going to have to look at that case separately. The work that I'm doing is valid if s is non-zero. The work I'm doing is invalid if s is 0. So that doesn't lead me to a conclusion either way about whether s is going to be included in the domain of my Laplace transform. That's an open question. Now, if you realize that, you might have started with case 1, what if s is equal to 0, and just get that out of the way. For most people, though, you start with the definition, and it doesn't occur to you that s being 0 could be a problem until you hit this point. So then just make a note. Okay, table that. We're going to have to look at the case that s is equal to 0 separately. We will come back and do that after we finish this task that we're in the middle of. So this is going to equal negative c over s. I'm just going to combine those constants. The integral from the u value at 0, negative s times 0 is still 0, to the u value at b would be negative s times b, e to the u du. Oh, I dropped my word limit. I'm so sorry. That should have been negative c over s times the limit as b goes to infinity. There we go. That's much better. All right, so that's negative c over s times the limit as b goes to infinity of e to the negative sb minus e to the 0. Now, of course, e to the 0 is just 1. Okay. What I'm concerned with is what this particular limit right here is, because that's the only part that involves b. Okay. So, if I take a look at that, the limit as b goes to infinity of e to the negative sb, there are two possibilities that I could get right here. If s is positive, this exponent will be going off to negative infinity, so this is going to be 0. But if s is negative, that's going to make this exponent go off to positive infinity, in which case we're going to get infinity. Now, if we get infinity here, that's going to cause the integral to diverge. Okay. So, s cannot be less than 0 because that will cause the integral to diverge. But I can see that because I've taken it to the point where I can see this is the limit that's going to determine whether I get a finite number or whether I get something divergent. In this particular case, if this goes off to infinity, the integral will actually go off to, let's see, s is negative in that case, okay? So it'll go off to negative c times, quote unquote, times negative infinity. So it will be, the sign of that will be, oh my goodness, I'm totally flubbing here. The sign of this would be infinity. S will introduce a negative, that will introduce another negative, it'll be the sign of c. So if c is positive, it would go off to infinity. If c is negative, it would go off to negative infinity. Okay, so that basically deals with two cases. If s is positive, we're going to get convergence. Let's see what we get if s is bigger than 0. So if s is bigger than 0, then I can say I'm getting negative c over s times 0 minus 1, which is just going to be c over s. Okay. Now, a lot of people said this limit was 0 without qualifying that it was only 0 if s was positive. At the time you're evaluating that limit, if there are restrictions on s that make that limit 0, you need to say them at that moment in time. It's not okay to say this limit is 0 and then 3 lines later say that s is positive, because then I don't see that there's a connection between them, that the reason this goes to 0 is because s is positive, and that's not true if s isn't positive. Okay. All right, so if s is positive, we get this. If s is negative, the integral is going to diverge. So now I just need to take a look at what happens if s is equal to 0. Now, if s is 0, I know I can't use a u substitution, so let's just look at how I would evaluate things. So if s equals 0, then I would get the integral from 0 to infinity of c times e to the negative 0 times t dt. Okay. That's going to be just the integral from 0 to infinity of c dt. Okay. Now, here, we're basically finding an area with an infinite base and a finite non-zero height. This is going to diverge. Now, there are a couple of ways I could see it. I could say it diverges. I could really say it diverges by inspection, but I'm just going to say it diverges because the integrand doesn't go to 0. If I'm going to get a convergent integral, the integrand would have to go to 0 as t goes to infinity. That doesn't. It's busy being c, and we said that c was non-zero. Okay. So, now I know that if s is equal to 0, my integral diverges. Therefore, I can put the pieces together, and I can say the Laplace transform of c is just going to be c over s if s is bigger than 0. But essentially, I looked at 3 different cases. If s was bigger than 0, it converges to c over s. If s was equal to 0, we get the integral from 0 to infinity of c dt, which diverges. And if s is less than 0, we get that it diverges because the limit as b goes to infinity of e to the negative sb is equal to infinity. Okay. So different reasons for excluding these two things. Okay. So your final answer will just involve this restriction on s. S has to be bigger than 0. But I need to see you addressing why can't it be 0 and why can't it be negative.